Alright, so let's talk about a special Taylor polynomial that we call a Maclaurin polynomial. Now, a Maclaurin polynomial is just a Taylor polynomial, but we center at 0. So apparently you can just center a polynomial any way you want and name it at yourself. For example, the Wernow polynomial is centered at pi. I'm just teasing, there's no Wernow polynomial, but there was. Pi would be a good place to center it from. So we want to write a Maclaurin polynomial of degree 4, so for f of x equals cosine of 3x. Now that degree 4, what that's telling me is that n here equals 4. So we want 4 derivatives. Now, because it's centered at 0, we also know c is 0. So what I'm first going to have to do is I have to find 4 derivatives for this function. So remember, because my rule is this for a polynomial, p sub n of x is the value of the nth derivative at c over n factorial times x minus c to the nth. This is our Taylor polynomial rule. So I need to find the value of all the derivatives at 0, and that's what this first part tells me to do. So what I'm going to do is I'm going to write out my derivatives. First, my function, f of x equals cosine of 3x. If I take the first derivative, we're going to get, what's that, negative 3 sine of 3x. Take the second derivative. Be careful, negative 9 cosine of 3x. The third derivative, be careful, positive 27 sine of 3x. And the fourth derivative, should have gone so far. I get, what's that? 81 cosine 3x. And there's our derivatives. Now, it's a Maclaurin, so what we're going to do now is we're going to find the value of each derivative at 0. So we're basically finding this part right here. So, and you could probably do this in your head. Cosine of 0, 1. If I plug it in 0 to the first 0 in here, that's just 0. The second derivative at 0, be careful, cosine of 0 is 1, so I'm multiplying it by negative 9. The value of my third derivative at 0, just 0. And the value of my fourth derivative at 0, be careful. Again, cosine of 0 is 1, but I'm multiplying it by 81. That's the hard part. Now we have to put it into our rule. So I want to find the Maclaurin polynomial, Taylor polynomial centered at 0 of degree 4. And that's what we're going to do here. So I plug in everything. Now be very careful. We didn't do this one in the last example. You want to be very careful. Up here, n is 0. So if I plug it into my rule here, I'm going to get 1 over 0 factorial, x minus 0, which is 0, to the 0, plus, go to my second one. My second value is just 0. Don't need anything with that one. Next one, minus 9, but be careful. N here is 2, so I divide that by 2 factorial, and I'm going to get x squared. Again, it's x minus 0 squared. And then plus 0, and then the next one, plus 81 over 4 factorial, so I'm on the fourth derivative, and this becomes just x to the fourth. Now I can clean this up a lot. This just 1 minus 9 over 2 factorial. Whoops, I'm looking factorial there. X squared plus 81 over 4 factorial x to the fourth. Now remember, what does this polynomial represent? This is saying that the cosine of 3x can be approximated by this polynomial. In other words, we can represent any function that is transcendental as a polynomial close to a certain degree. So let's take a look at a slightly harder one. Again, a Maclaurin one. Okay. So let's try a different one here. Give me a second. Maybe not. Here we go. So what happens if we might have e to the x? Well, let's take a look. Well, let's take again number 2, a Maclaurin. Remember Maclaurin. C is centered at 0. Let's take a look at a degree. Let's say 4 again. N equals 4. And let's let the function of f of x equals, let's say e to the 1/2 x. I don't know. So I want to find a polynomial function that looks exactly like this exponential function near 0. So I just write it down. F of x. I need the derivatives. Remember my rule, right? My rule to get the polynomial, it's just going to be the value of the derivative at c over n factorial times x minus c to the n. So I'm looking to find these values right now. So e to the 1/2 x. My first derivative, what I use fractions, 1/2 e to the 1/2 x. My second derivative becomes 1/4 e to the 1/2 x. And my third derivative, what's that? 1/8 e to the 1/2 x. And my fourth derivative, 1/16 e to the 1/2 x. Now, because it is Maclaurin, right? Now I'm looking for these values at 0. Because it is Maclaurin, I want to find the values at 0. Here, easy. 1. F prime of 0, just 1/2. The second derivative at 0, 1/4. The third derivative at 0, 1/8. And the fourth derivative at 0, 1/16. So now I'm ready to write out my polynomial. My Maclaurin polynomial of 4th degree. Maclaurin, you can do your best Irish. Hi, I'm Maclaurin, and you will find my series. Okay, that was terrible, I'll admit. So I plug it all in. This becomes 1. Now recall, this is n equals 0. So we're going to go 1 over 0 factorial. It's like the 0th derivative, just a function, times x to the 0 plus 1/2. Now, over 1 factorial. We'll talk about all this stuff in a second. And this is going to be x to the first. Plus, so that should be a plus there, 1/2. 1/4 over 2 factorial. And this becomes x squared plus 1/8 over 3 factorial x cubed. Plus, now where am I getting these from? This 1 over 16, that's my value, 1 over 16, over n factorial, that's my degree, or my derivative, my fourth derivative, x to the 4th. It's really x minus 0. Now, we don't like this, that just looks nasty. So we're going to rewrite this. This is just 1 plus, and you can write this as 1 over just, in this case right here, 2x plus, now you can simplify this one, 1 over, that's just 2, times 4 is 8, x squared, plus, again, this is just 6 if you want to. So I can write this as 1 times, I don't know what 8 times 6 is, what's that, 54? Yeah, I'm embarrassing myself. 8 times 6, oh, that's 48. See, told you, I can't multiply to save my life sometimes. X cubed. Now this one, forget it. 24 times 16, not going to happen. So what I'll do, I can write it like this way. 1 over 16 times 4 factorial x to the 4th. And remember what this means. E to the 1/2 x is about this polynomial. They are near 0. These will look exactly alike. And graph it to see it. Now, if you go to part 3, we'll take a look at what happens if we have a series, or what happens if we're not going to be centered around x equals 0. We'll take a look at an example there.